Welcome back. Today, Docker. You'll use it in week one of almost any job to run the backend, the database, sometimes the whole company on your laptop. By the end of this video, you'll know what containers actually are, and we'll spin up a real Postgres database with a single command. Let's start with the problem Docker solves. Software doesn't run in a vacuum. It depends on a specific runtime version, system libraries, environment variables, a database being present. Your app works on your laptop because your laptop happens to have all of that. Your teammate's laptop doesn't, and neither does the production server. So things break in ways that are miserable to debug, and someone says the four most expensive words in software works on my machine. Teams used to fight this with long setup documents, install this, configure that, which drift out of date immediately. Docker's answer is different. Stop shipping instructions, ship the environment itself. Two words carry all of Docker: image and container. An image is a frozen snapshot of an environment, a file system with everything installed. An operating system base, your runtime, your libraries, your app, your configuration. It's built once and it's immutable. A container is a running instance of an image. Same relationship as a class and an object, or a recipe and a cake. From one image, you can start one container or 50, and every single one is identical. That's the magic. If the image runs on your machine, it runs the same way on your teammate's machine and on the server, because the environment travels with it. Images are also layered. Each build step adds a layer, and layers are cached and shared. Two images based on the same Ubuntu base share that base on disk. That's why the second image you download is much faster than the first. Isn't that just a virtual machine? Close, but no, and the difference matters. A virtual machine emulates an entire computer. Every VM boots its own full operating system. That's heavyweight, gigabytes each, and slow to start. Containers share the host machine's operating system kernel. Isolation comes from operating system features that wall off each container's processes, file system, and network, not from booting a separate OS. The result: containers are megabytes instead of gigabytes, and they start in about a second instead of a minute. That's why you can casually run 5 containers on a laptop: your API, your database, your cache, and still have RAM left for your browser tabs. The trade-off: containers are a bit less isolated than VMs, which is why clouds still run your containers inside VMs under the hood. But at the developer level, containers won. Where do images come from? A Dockerfile, a short text file of build instructions. This one says, start from an official node, 20 image, set a working directory, copy in the dependency manifest, install dependencies, copy the source code, and declare the start command. Run docker build and out comes an image. Notice we copy package.json and install dependencies before copying the rest of the code. Because layers are cached, editing your source won't re-trigger the slow install step. Little ordering tricks like that make rebuilds fast. Finished images live in registries. Docker Hub is the public one, and companies run private ones. Docker push uploads, Docker pull downloads. This is exactly how you'll get Postgres in a second. The Postgres maintainers publish an official image, and you just pull it. Let's run a real database. One command, and it looks scary, so we'll take it flag by flag. Docker run creates and starts a container. -- name FlyRank or EDB just gives it a friendly name. The two -e flags set environment variables. That's how the Postgres image configures itself. We're setting the password and asking it to create a database called FlyRank on first boot. -p5432 to 5432 is port mapping. Containers are isolated, remember? Nothing gets in or out unless you open a door. This publishes the container's Postgres port onto your machine's port 5432, so your app can connect to localhost 5432 as if Postgres were installed natively. -v mounts a volume. Here's a crucial rule. A container's internal file system is disposable. Delete the container, lose the data. A volume is managed storage that lives outside the container, mounted into it. Our database files survive even if we destroy and recreate the container. -D runs it detached, in the background. And Postgres, 16 is the image. Name, version tag. Docker pulls it from Docker Hub automatically if you don't have it. And that's it. A production-grade database, running locally, in seconds, with nothing installed on your machine except Docker itself. The handful of commands you'll actually use daily. Docker ps lists running containers. Docker logs streams a container's output. First stop when something's broken. Docker exec runs a command inside a running container. Here that drops us into PSQL, the Postgres shell, right inside the container. Docker stop and start do what they say, and Docker rm deletes the container, while our volume keeps the data safe. Real projects aren't one container. They're an API, a database, maybe a cache. Typing long Docker run commands for each gets old fast. Docker Compose fixes that. You describe every service in one YAML file, then start the whole stack with Docker Compose up. Look closely at the database URL. The host isn't localhost, it's DB, the service name. Compose puts all services on a shared network where each one is reachable by name. This file is the modern replacement for the setup document. A new teammate clones the repo, runs one command, and has the entire environment. This is what you'll most likely encounter on day one at FlyRank or anywhere else. Recap: Docker packages environments, so software runs the same everywhere. Images are immutable snapshots. Containers are running instances. Containers share the host kernel, lighter and faster than VMs. Ports let traffic in, volumes make data survive, and Compose describes multi-service stacks in one file. Next time, we look at Supabase, how you get a full backend, including that Postgres database as a service. See you there.